This is the day one notes for graphing systems of linear inequalities. So we've already graphed linear inequalities where we were just graphing one inequality on a coordinate plane, and we've covered systems of linear equations. So this lesson kind of takes those two skills and puts them together. So notice that I have two inequalities, which is what it takes in order to make a system of inequalities, and they are both lines. So because they are linear, I'm going to graph them on this coordinate plane, and I'm going to look for the solution of the system. So it is similar to our system of linear equations, but slightly different because it's going to use those skills that we used when we were graphing inequalities. So looking at this first one, I notice that that is x equals a number, so I know I'm using VUX on that. Remember, VUX helps me remember that vertical lines are x equals. So since this just has x is greater than 5, I am going to go to 5 on the x-axis, and I am going to place a point, and I know that I need a vertical line passing through that. However, because this symbol is just greater, I know that that line is actually a dashed line. Because of what I learned when I was graphing inequalities, I know that it's only if it has a little line under it, like this second one, the equal to, that my line is solid. So remember, we use the dashed line to tell us that the ordered pairs that fall on my line are not part of the solution here, okay? If I want the numbers that are greater than that, that means I'm going to be shading to this side. And this is where it's new. Notice I'm not actually shading. What I did was I drew little arrows pointing to the right because that's where I would be shading my solutions. However, since this is a system, I know that the solution has to work in both inequalities. So my second inequality is y is less than or equal to 4. Since I only see y, I know that's HOI. Remember, HOI is supposed to help us remember that horizontal lines are y equals. So I'm going to go to 4 on the y-axis, and I'm going to put a point. Now this time my symbol has the equal to, so I know that my line is solid through that point. Notice it was a horizontal line, so I drew a horizontal line. And I want the numbers that are less than or equal to, so that would be shading below this line. Notice once again that I put arrows pointing down, but I didn't actually shade. Now, in order to be a solution of the system, I'm only looking at where that shading would overlap. So notice right here, this rectangular portion that's showing in my coordinate plane is the only place that would be shaded both green and blue. So when I shade, my solution is only the things that fall in the green and blue area of the inequality. So that would be everything in this region over here as my solution. There are other shaded areas on the graph. If I was to have shaded, this would be green and this would be blue, but we need the overlapping shaded region in order to show the system's solution. Okay, let's go ahead and move forward. So here I have another system of linear inequalities. I know that it is linear because it satisfies the linear. It has x and y in these. It's in slope-intercept form, and it's an inequality because it doesn't have an equal sign. It has the less than or equal to and the less than sign. So in order to graph these, I'm going to use the slope-intercept form. So the first equation, or inequality, I'm going to graph in blue. So I'm going to start on my y-intercept, which is 3, and I'm going to put a point. My slope here is positive 2, so I'm going to rise 2 and run 1 and put another point. And you could do that as many times as necessary to get your line. Now on this one, I notice that it's less than or equal to, so I know that this is going to be a solid line passing through those points. And since it's less than or equal to, if I put my pencil on my y-intercept and I draw my arrows, I notice that I would be shading below the line. Notice once again, I'm not actually shading because I'm looking for the overlapping shaded region. So I'm going to graph this one before I shade. So once again, I'm going to start on my y-intercept, which is positive 1, which is right there on the y-axis. My slope is negative 1, so I'm going to go down 1 and to the right 1 this time. This time my symbol is just less than, so I know that this is just a dashed line passing through those points. And since it is less than, I know that I would be shading below the y-intercept, which would be over here. Now, where would the overlapping shaded region be? You can tell where it would be overlapping because there should be blue and green arrows pointing in that direction. So the overlapping region would occur right here in this little triangular region between the lines, which is what I am going to shade in. When you are shading on your paper, you need to be as careful as possible so that I can actually see that your line is dashed, if it is indeed dashed, and that I can tell where the overlapping region is. What you're trying to tell me is the solution set. Okay, so the solutions are all the ordered pairs that fall within this shaded region. Okay, let's try another one that has a little bit more work than this one. So we did vertical and horizontal. We did two that are already written in slope-intercept form. So now we're going to move on to some where we have to manipulate the equations before we can solve. Okay, so notice that these are not written in slope-intercept form, which means that I need to solve for y. On that first equation, if I have 2x plus y is greater than, that symbol, let me erase and try that again, greater than or equal to 4. In order to get y by itself, I would subtract 2x from both sides, which would leave me with y is greater than or equal to negative 2x plus 4. That means I place my first point on the y-axis at 4, and my slope is negative 2, so I'm going to go down 2 and over 1 to get another point on my graph. This is greater than or equal to, so I know I'm going to use a straight edge, and I am going to draw a solid line through those points. And it is greater than, so if I put my pencil on my y-intercept, I know that the numbers that are greater than that would be above this line. So I know I'm going to shade up. Let's go ahead and do that second line. So we have 3x minus y is less than or equal to 6. The first thing I'm going to do to isolate y is to subtract 3x from both sides. I'm going to bring down my negative y is less than or equal to negative 3x plus 6. Don't forget, when we learned inequalities, we know that if we divide by a negative, which I'm doing here, I'm going to have to reverse this symbol. So I'm going to get y is less than, not less than, it's already less than, y is greater than or equal to positive 3x minus 6. One of the most missed things is when you divide by a negative, you have to remember to reverse your inequality symbol. Okay? So from here, I am going to graph, which means I am putting my first point on negative 6 because that was the y-intercept right here, that's b. And now I'm using my slope, which is positive 3. So I'm going to rise 3, run 1. Now this time it's greater than or equal to, so I am drawing a solid line through those points. Now hopefully if you were graphing on your paper, your lines would be more accurate than what mine are graphing on my iPad, but you should be using a straight edge. If you need to rise and run some more to get some points so that your lines are more, accurate, then go ahead and do that. Okay, it says greater than or equal to, so if I put my pencil on my y-intercept and I draw my arrows, I know I would be shading above that line, which makes the overlapping region occur inside here for our solution. Now I'm going to take a minute just to kind of talk about the solution set here because that is something that we talked about in class today on our notes. So this particular problem, if I asked you for, let's say, 2 ordered pairs that were part of the solution of this inequality, I'm looking for ordered pairs that fall inside this shaded region Or, since these happen to both be solid lines, I could use that point of intersection if I could see it clearly on my graph, okay? For example, one of the solutions for this inequality could be, let's say, 0, 5. Because 0, 5 falls right, 1, 2, 3, 4, 5 is right there on my coordinate plane, which is in the overlapping shaded region. So if I was to plug 0, 5 into these inequalities, it would satisfy both of them. So I could do 2 times 0 plus 5. Well, that's 5. Is 5 greater than or equal to 4? Yes, it is. I could plug it in here. 3 times 0 is also 0, minus 5. So is negative 5 less than or equal to 6? Yes, it is. So it works in both inequalities. Any ordered pair that falls in the shaded region is going to work for both inequalities because it's part of the solution. Now, if I was looking for a non-solution, that would be any ordered pair that falls in the unshaded region, okay? So I could pick negative 2, 0, or negative 2, 3, or any ordered pair that would fall in this white area on my graph. Okay? It has to fall in the overlapping shaded region to be considered a solution. So this was day 1 of graphing systems of linear inequalities, and we talked about those solutions. We will take another day to work on this, but if you're having any issues and this video was not enough support, then please come in for tutoring. You'll have a great day.